Okay, now in this lecture, we will discuss about derivatives of exponential and logarithm. So this is the last topic of my chapter number 3. So which contains 3.9.1, that is exponential derivatives, then logarithmic, and then derivatives to determine the derivative of a function. Let's start. Okay, so in case of uh, derivative of natural exponential function. So this derivative will be this derivative, let us say that ex equals to e power x be a natural logarithm. Then so derivative of, let's say, ex is my function having natural logarithm e of x. So derivative of a natural logarithm is same as that of the exponential value, and then the derivative with respect to x, so this value will be 1. So in case of egx, now my x function is replaced by what? Gx. So it will be derivative will be egx, then the derivative of this function, that is derivative of g of x. Okay, so let's start on an example. We have to find the derivative of my function whose value equals to e and then 10 with 2x. Okay, so first thing, for derivative, f derivative of x will be e 10 2x, then taking the derivative of this function, so it will be d upon dx of what? 10 2x. Just give me 1 second. Okay, I have to share it again, this one. So now, so it will be f of x, which will be equals to f derivative of f, which will be equal to e tan 2x with derivative of function that is tan 2 of x. Okay. So e tan x will be e tan 2x will be same. Just we have to take the derivative of tan 2x. So derivative of tan equals to secant square x. So it would be secant square of, that is function is 2 of x, then taking also the derivative of 2 of x. So it is t of tx of what? 2 of x. So this value will be 2. So it will be e tan 2x with secant square 2x with this derivative, it equals to 2. So this is the answer of my फंक्शन वैल्यू विच इज ई टेन टू एक्स. तो ये मेरे पास मेथड है जिसमें हम अपने फंक्शन का कोई भी एक्सपोनेंशियल फंक्शन का डेरिवेटिव फाइंड करते हैं. ओके, so let's move towards the next slide. Now this is the combining the differentiation, or then there is a e and also an x. So for this it will be what? When I take the derivative, y derivative. So as this is in numerator and denominator, so I will take the I will apply the quotient rule. So it will be denominator square, so it will be x square, then denominator as it is, derivative of numerator, so derivative of ex power 2, so it will be ex power 2, then the derivative of my function, that is x2. So x2 derivative will be 2x. Okay, so it will be 2x. uh, then it will be minus derivative of denominator. So it will be x denominator will be 1 into denominator as it is. So it e to x will be this one. Now taking common, what here it is the common e x power 2. So taking e x power 2 common, so this will be eliminated and this will be eliminated. So it will be 2x into x, that is 2x square. Then a minus, here it is only 1 divided by x square. So here we apply quotient rule, and also in the derivative portion I also apply the exponential rule. Okay, now apply the natural logarithm. As a colony of mosquitoes have an initial population of 1000. Okay, after t days the population is this one. Show that the ratio of rate of change of population, that I have to find the derivative. So it will be what? It will be a derivative of t. So it will be written as, how to find the derivative. So after this derivative will be 1000, then taking the derivative of e, so it will be e 0.3t, and then taking the derivative with respect to time of value 0.3t. So it will be 1000 e 0.3t, and from here it will be 0.3. The derivative of 0.3t is 0.3. Then I have to multiply 0.3 with the 1000. So my value will be 300 e power 0.3t. So this is the answer of my derivative function. So as it will be, so that's the I have to find also the ratio. Uh, so ratio of what? Ratio of my ratio of this will be the derivative function, this one, 300 e 0.3t divided by the original function, that is my 1000 e power 0.3t. So it will be 1000 e power 0.3t. This will be cancelled out this one, so my answer will be 0.3. Now derivative of logarithmic function. So how to take the log? let's say let's say my function is y equals to ln x. So derivation of my log x is always this log x will be, this log will be written as 1 upon x, that it will be reciprocal always. If there is log x square, so it will be log x square into d upon dx of function. So let's move towards the example. Let us say I have a function value, that is f of x equals to log x cube plus 3x minus 4. So derivative will be 1 upon value, that is x cube plus 3x minus 4. Then taking the derivative of this function value, that is x cube plus 3x minus 4. So it will be 1 upon x cube plus 3x minus 4 into taking the derivative, that 3x square plus 3. So it will be 3x square plus 3 whole divided by x cube plus 3x minus 4. So this is the answer of this derivation. Okay. Now using the properties of logarithm, we have to solve this. So here I don't derive, but I only use the properties of logarithm. Okay, so here it is function of what? Function of log of x squared sine x divided by 2x plus 2. First I have to apply the property, then after I have to, because I also have to derive then. Okay, so it will be f of x will be written as, okay, so it will be written as, firstly I have to log x square sine of x divided by log 2x plus 1. So first it will be written as, there's a multiplication of two variables. Okay, so you have to remember that when there is a multiplication in logarithm, this will be written as in sum. Okay, so it will be log x square plus log sine x. Then the next one is this one, which is in denominator and which basically divide with this parameter. So when there's a division in my logarithm, so it will be written as negative after the application of property. So negative of log 2x plus 1. Okay. Now again, I have to apply here some property that if there is a square, so this square will be written here before the log. So it will be 2 log x plus log of this value, that is sine x, minus log of the next value, that is 2x plus 1. So what is 2 will be written here. Now first I have to apply the derivative. So my derivative will be, log x will be 1 upon x plus log of sine will be written as what? It will be written as, it will be written as 1 upon sine x. Okay, and then the derivative of my function, that is d upon dx of my value sine x. Okay, then minus of log, this is the function, so 1 upon 2x plus 1, this is the property of logarithm. After, then I have to derive my function, that is 2x, derivate my function, that is derivation of 2x plus 1. So my answer will be 2 for this. Okay, so I have to write here again, so it will be written as 2 upon x plus derivation of uh, sine will be cos, so it will be cos x divided by sine x minus 2 upon 2x plus 1. As I know that tan equals to sine upon x, sine upon cos, and the inverse of sine is cos. So cot will be cos upon sine. As this value is cos upon sine, so I will write this value as cot x. So it would be 2x plus cot x minus 2 upon 2x plus 1. Okay, now this is basically, if y equals to this one, log of bx, so it will be written as derivative of my function 1 upon log of b. Okay, log of b, and then this value x. Okay, so let us say this value will be, if there is some parameter or some derivative parameter g of x. Okay, so it will be written as 1 upon gx log b, and then the derivative of this function, that is d upon dx of g of x, that will be written here. Okay, if y equals to bx, so it will be written as log b. Okay, So bx 10 log b if uh, b uh, power gx, so it will be b gx, then derivative first b gx log b, then taking the derivative of it. So this is the general formula to define. Again, I have to elaborate here. Just give me 1 minute. That is, when there is y equals to log bx, so the derivative will be y derivative will be written as 1 upon x log b. Okay. In the second case, when y equals to b power x, so it will be written as y derivative will be bx log of b. Applying the derivative formula here, so it will be written as h derivative will be as the division of two variables, that is 3x and second is 3x plus 2. So I will apply my quotient rule. So it will be derivative square. So 3x plus 2 square, denominator as it is, that is 3x plus 2. Now this is 3x. So after the application, so it will be 3x, then log of this parameter, so log 3. Okay, then minus nominator as it is, so it will be 3 of x, then the function of my derivative of my denominator, so it will be written as 3x log of 3 plus 2, mean that the derivation of constant equals to 0. So here we apply the y equals to bx. Okay, the formula I written in previous slide. So this value equals to what? The derivative equals to b of x, then log b. Okay. In our case, it is y equals to, let's say, 3 of x. Here it is 3 of x. Okay. So derivative will be 3 of x, then log of b. This is my b, so it is log 3. So this is the formula which basically used in the derivation. So this will be 3x log 3 with 3x plus 2, then minus 3x log 3 with 3x whole divided by 3x plus 2 whole square. Now taking some common, so this value is it will be the common, so it will be 3x log of 3 into 3x plus 2, and then a minus 3x, okay, divided by 3x plus 2 whole square. This value and this value will be cancelled out, so it will be 2 into 3x log of 3 whole divided by 3x plus 2 whole square. Okay. Now using this, we have to find the slope of a tangent line. So to find the slope of a given tangent line, let us say that my value is this one, dy y equals to log of 2 into 3 of x. So the derivation will be dy upon dx will be this value, that is 1 upon 3x plus 1, then this is log of 2, then taking the derivative of my function, that is d upon dx of 3x plus 1. Okay, so this is basically, this is given here, I apply this formula. Okay, so this is the formula, 1 upon this formula. I have to change the color. Okay, so this basically this formula, which is d upon dx of this one. Okay, so I have to raise it. Let's move towards the question. So this will be derivative will be 1 upon log ln 2 with 3x plus 1. The derivation of this will be 3, so it will be written as 3 upon ln 2. Now applying x equals to 1, so 3 and x 3 multiply 1, so 3 plus 1, that will be 4. So I will write 3 upon 3 4 ln 2. So this 4 will be written here according to property test, that will be written as the formula, as in the power. So it will be 3 upon log 2 power 4. So we will write that 3 upon 2 power 4 will be log 16. Okay. Now logarithmic differentiation. So these are the thumb rules. So you have to to elaborate this. This is problem solving strategy using logarithmic differentiation. So to differentiate, let's say y equals to h of x. Okay, using logarithmic differentiation, take the natural log, that is if there is y equals to h of x. So first step number one is to take the log x ln on both sides, so ln y and ln h of x. Okay, this is the first step. So use the properties to expand this. You have to use the properties of log to expand as soon as basically as simple as possible. Okay, so then differentiate on the both sides. So on the left side, I have to I will left here that 1 upon y and dy upon dx, and all other parameters on the right hand side. So multiply both sides by of the equation by y. So I have to multiply y on both sides, y here and y here. Y and y will be cancel out, and this will be my value, or my final equation after derivation. Okay, let's move towards a question. That's one. Let us say that I have a function that y equals to this one. So first step is to take the log on both sides. Log y equals to log of 2x power 4 plus 1 with tan of x. So it will be written as after taking the derivative. Sorry, after taking the log on both sides, now I have to simplify my right hand side. So log of this one, as this tan x is in power, so this will be written before my log. So it will be tan x, then log of ln of 2x power 4 प्लस 1. इसके बाद हमने log of ln y को डिफरेंशिएट करना है. So this will be 1 upon y dy upon dx, and then I have to apply product rule here. So because this is the first variable and this is the second variable, so how to apply? So it will be derivative of first, that is secant derivative, so it will be secant square as x, and then second as it is, so it is log of 2x power 4 plus 1, then plus first as it is, that is tan x, taking the log, so it will be 1 upon 2x power 4 plus 1, then taking the derivative of this function. So this will be 2 into 4x3 and plus 0. Okay, so it I will write here, so 1 upon y dy upon dx equals to secant square x log of 2x4 plus 1 plus 10 x into this will be 2 multiplied 4x cube, so it will be 8x cube divided by 2x4 plus 1. Now multiply y on both sides, so it will be y here and y here, so this y and this y will be cancelled out, so this dy upon dx will be dy upon dx will be, as this is y, so what is the value of y value is this one, so I have to put this y here, so it will be 2x 4 plus 1 10 of x, then taking all this value, so it will be secant square x log of 2x power 4 plus 1 plus 8x cube divided by 2x4 plus 1 with 10 of x. So this is the derivative of my equation. Okay, again use the logarithmic differentiation for this one. So this will be the important question. So it will be written as log. First I have to take log on both sides, so I will take here, so it will taking log on both sides. Okay, so after taking log, uh, compute it and simplify it, so it will be, first it will be log x and then plus log under root 2x plus 1, so under root mean 1 upon 2 and then 1 upon 2 is in power, so it will be taken before the log by applying the properties of logarithm. Then this value is basically in denominator, as when I apply the logarithm, this is the power, so this power will be written before the log, so it will be x log e, then minus, then this 3 will be also written before the log, so minus 3 ln x. Okay, then I have to apply the logarithm, so when I apply the logarithm, to 1 upon log ln y will be 1 upon y dy upon dx, log of x will be 1 upon x, this will be written as log of 2x plus 1, so it will be 1 upon 2x plus 1, and taking the derivative of this function, that is 2x, so then 2 and 2 will be cancelled out, and this is the value. Then there is x into ln e. So what does this mean? So this means that the value of ln e equals to 1 and the derivative of x equals to 1. Okay, so then 3 into log of sine x, so it will be 3, sine x will be written as 1 upon sine upon cos, so it will be reciprocate here. So I will derive this, it will be written as 3, and then log of x will be 1 upon sine x. Okay, 1 upon sine x, then the derivative of the function, that is sine x, so derivative of sine equals to cos x, so it will be written as cos upon sine, as cos upon sine equals to cot, so it will be written here, also here. Now taking the y on both sides, taking so this y will be cancelled out y, and here y will be multiply, and then compute this y value from this equation, and this is my final answer. Okay, so this is the important question of this lecture. Now extending the rules, or extending the power rule, as y equals to x power r, taking log, this is Sam taking log on both sides, so this will be um, log y equals to log x power r, then take this power here, so it will be r ln x, so then taking the derivative, so it will be 1 upon y into dy upon dx, and this derivative this log will be 1 upon x, then I have to multiply y on both sides, so y and y will be cancelled out, so y r upon x. Then what is the value of y? y value is this one, that is x power r. So x power r into r upon x. Okay, so after this it will be xr. I have, this is basically dy upon dx will be x upon x power r multiply by r, and then this x will be denominator when it goes in upward in numerator, so the power will be negative. So there is a x xr and x negative r, so it will be r x r minus 1. So this is the derivation of my function y equal to x power r. So this is it. This is the completion of chapter number 3. So hope to understand each and every point. So we'll meet in the next lecture, inshallah.